example 2, suppose f is invertible with f of 0 equals 1 and f prime of 0 equals 2. So f being an invertible function means it has an inverse. F of 0 is 1. What does that mean? Well, graphically, that means when you plug in x equals 0, you're going to get y equals 1. So we get the point 0, 1 on the graph of the original function. And then we're told that the derivative at 0 is 2. So the fact the derivative exists tells us the function's locally linear. It's got a slope of positive 2. That means it looks something like that. So we're asked to find the derivative of the inverse at 1. Okay, well, how do we get the inverse? To get the inverse, we switch the inputs and outputs. So we switch the x and y's. And that puts up a symmetry here about the line y equals x. So the point 0, 1 is going to go to the point 1, comma 0. And the tangent line will flip over to become the new tangent line. And since the x's and y's switch, what used to be delta y over delta x here, which gave us a ratio of 2, is going to flip over. So the ratio delta y over delta x here is going to be the reciprocal of what it used to be. That gives us the slope as a half. So that tells us that the derivative of the inverse at 1 is a half. All right, write the equation of the tangent line to y equals f inverse of x when x equals 1. So we got our tangent line formula, y equals. We need the derivative of the function at 1 times x minus 1 plus the inverse at 1. The derivative of the inverse at 1, that's our slope, that's a half, times x minus 1. F inverse of 1, that's the y value on the graph, which is 0. And so we get y equals 1/2 x minus a half. And that'll do it for example 2.